Hi there, welcome to this video. Thanks for clicking on and watching. Hopefully you've done so because you are starting Maths A-Level in September. Well done and congratulations on completing your GCSEs. But now looking towards starting your A-Levels, you would like to make the best start and bridge that gap, step up to your A-Level and do some transition work over the summer. Well, this is exactly what we're going to run through in this video. So let's get started. In this video, I'm going to focus mostly on the Edexcel exam board, but all the exam boards have pretty similar syllabus. For the Edexcel exam, a lot of schools don't do ASs anymore, but the A2 at the end of the upper six, you will sit 3 papers and each paper is equally weighted towards your end result. 2 pure papers, both 2 hours long. Any topic can come on either of those, and then paper 3 is the applied paper, which is statistics and mechanics, also 2 hours long. So if you are thinking of doing Maths A-Level, you really need one of these white ClassWiz calculators. They are essential. You can buy them from between £20 and £30 and they're going to be really useful. They've got the stats mode, which is essential for completing the statistics course. You're going to be able to check your answers for integration on there, which you will meet in the lower six. And you will also be able to solve simultaneous equations and find factors of quadratics just from keying in the equations into the calculator. Here are the front covers of the 2 textbooks. Now these are the AS level year 1 and then you will get the same again, a blue and a brown one for year 2. The blue is the pure one and the brown one is the applied stats and mechanics. So here we have a list of all the different chapters and topics in both of the books for AS. In the blue book, the pure book, looking down this list, you'll recognize some of these words. You might not have met logarithms, although you might have heard of that word, and you might not have met differentiation or integration. But this is a branch of maths called calculus, and you will definitely meet that in the lower six and then build on it more in the upper six. Looking at the stats and mechanics, the brown book, you can see some words here. You will have met probability. Even if you didn't do any sampling, you know that to take a sample, taking a small proportion of the population and analysing that. You might not know what a distribution is and hypothesis testing, but you can see that the beginning of the A-level does contain some words and some topics that you will be familiar, and then you will build on it. In the mechanics, it's all to do with kinematics, which is the study of motion. So you're going to meet Newton's 3 laws and look at forces and motion. So on the basis of all those chapters and the contents of year 1, here is a list of topics that you would benefit from looking at over the summer. So for your pure maths, definitely looking at quadratics, all the different ways you can solve them, looking at indices, surds, inequalities, knowing your transformations of graphs, being really solid on your trigonometry, being able to manipulate algebra and have a good understanding of equations of straight lines and your circle theorems. For stats, looking at Venn diagrams, cumulative frequency and box plots, ranges and averages, so looking at the spread and the data location, probability and tree diagrams, familiarizing yourself with a histogram because you do look at histograms and look at them slightly different at A-level, being able to comment on results and trends and interpret the information that you're getting from all your charts and graphs. So let's now have a look at the maths that it's going to be really useful for you to have a look at and recap before you start your maths A-level. So looking at quadratics, quadratics can be solved in 3 ways. You can factorize, you can complete the square, or you can use the quadratic formula. Now I have got a simple quadratic here and I'm going to solve it in each of the three ways. Of course, if it can factorise, that's the easiest method to apply. So once you've solved it, you would only use one way. But just because it's a simple one, we can see that all three ways are going to work. So here, factorising into two brackets, two numbers that times together to give us 3 and add together to give us 4. Signs have got to be the same and positives are involved, so it's going to be both positive, and we're going to have a 3 and 1. Equal to 0, two brackets timesing together to equal to 0. We then choose the value of x to make each bracket 0, so x is going to be -3, or x is equal to -1. Now when you did this at GCSE, you might have just left it there, but at A level, seeing the links between the algebra and the graphs, what happens when you are plotting y equals this quadratic function? Where is y equal to 0? Y is equal to 0 when you are on the x-axis. So by getting these answers, -3, 1, you have found the coordinates -3, 0 and -1, 0. And these are the roots of the quadratic. We know it goes through at -3 and -1, and we know the shape of the quadratic. It's going to be our parabola like that. So let's have a go at completing the square. When you complete the square, you half the b and you look at the bracket x plus 2 all squared. That is making the square. Now if you FOIL that out, you put the two brackets next to each other and expand, you will get x plus 2 times x plus 2. You're going to get the x squared, the 2x there from the outers, the 2x there from the inners, but you're also going to get a plus 4. We don't want a plus 4, we want a plus 3. So if we take away that plus 4 that you're going to get and then bring down what we do want, which is the plus 3, and then of course we've still got the equal to 0 on the end, and then all we need to do is tidy up this last bit. So you're going to have x plus 2 all squared minus 1. Now when you're in completed square form, you've gone from having x appearing twice in the question to x just appearing once, and to solve you just unravel and get x on its own. So x plus 2 all squared would equal 1. X plus 2 would then equal plus or minus the square root of 1, which is just 1. So then x would equal -2 plus or minus 1. And they are just the answers that we've just got. -2 plus 1 will be -1, or -2 minus 1 will be -3. So we've got the same answers that we just got when we factorised. Now if we use the quadratic formula is just applying completed square with our ax squared plus bx plus c. So if you complete the square on this expression, out will come the quadratic formula that x is equal to minus b plus or minus b squared minus 4ac all over 2a. So in our question here, we've got a is equal to 1, b is equal to plus 4, and c is equal to 3. So using the quadratic formula, x is equal to -4 plus or minus the square root of the b, so that's going to be 16, minus 4 times 1 times 3 all over 2a, which will be 2. So that will be -4 plus or minus 16 minus 12 is going to be 4, and the square root of 4 is going to be 2 all over 2, and you can see that is again going to give us -2 plus or minus 1, just dividing both the numerators by the 2 from the denominator, and again it's going to give us x is equal to -1 or x is equal to -3. Here we can see we've got a more complicated quadratic because we've got a 3 in front of the x squared and we've not got equal to 0. So the first thing to do would be to take that 2x to the other side. Taking 2x off both sides, we'd get 3x squared plus 3x minus 1 is equal to 0. Then we'd try and solve that quadratic. It's always worth seeing if it would factorize. So in order to get the 3x squared, we'd have a 3x and an x. Signs have to be different and two numbers have to times together to give us 1. Well, they're going to have to be 1 and 1. Now, no matter whether we have a plus here and a minus there or the signs the other way around, when we do the outers and the inners, we're not going to collect to get that 3x in the middle. So it's not going to factorize. So we need another way to solve this quadratic. So we might complete the square. Now when you complete the square, you cannot complete the square with the 3 in front. So I might take 3 out and x squared plus x and then leave the minus 1 on the end. So when that 3 multiplies back up, I'd get the first two terms again. But when I complete the square, I'm going to do it on this bracket here, and I've got a 1 in front of the x. We need to half the b position to complete the square. And when I've got odd numbers, I'm going to start to get fractions. So I'm going to have a half there or decimals. So I think it might be a better idea to use the quadratic formula. So x is going to equal minus b, so that's minus 3 plus or minus b squared, which is 9. Minus, and then I use brackets for the 4ac, so it's 4 times a, and c you have to say is going to be minus 1, so have the sign as well, all over 2a, which is going to be 6. Now BidMaths tells us to do a times first before we will take all of that second term in the under the root away. So this is going to be x is equal to minus 3 plus or minus the square root of 9 minus 12 all over 6. So that will be minus 3 plus or minus 9 plus 12, which is going to be the square root of 21 all over 6. So then you would get your calculator out and you would give your answers. The default at A level as well as GCSE is to give answers to 3 significant figures. Now, of course, the plus or minus means you're just going to get 2 answers, minus 3 plus root 21 over 6, or minus 3 minus root 21 over 6. In this next question, we're being asked, where is this quadratic above 0 for all real values of x? So when we plot a quadratic, we plot y is equal to the quadratic, and in this case it's x squared minus 8x plus 17. When we solve it, we equate it to 0. And really, we're looking for when y is equal to 0. When y is equal to 0, we are on the x-axis, because all the way along the x-axis, you haven't gone up, you haven't gone down in terms of coordinates. So if we want our quadratic to be all above 0, it means that our quadratic graph has to be somewhere above the x-axis. Now, when we solve a quadratic equal to 0, we either get one answer, 2 answers, or no answers. And I can see that this particular quadratic is not going to factorize. I can't have two numbers that times together to give me 17. Signs need to be the same, negatives are involved, but when I do my outers and inners, I'm not going to get that minus 8x, so it doesn't factorize. So if I wanted to solve it, I would use the quadratic formula. But because I know I'm being asked to show that this graph is all above 0, I know that when I use the quadratic formula, the way I get 2 answers is when I do the plus or minus. The plus answer gives me 1 answer and then the minus. So what gives me 2 answers is when this expression under the square root is going to be positive, because when that b squared minus 4ac is equal to 0, I'm just going to get 1 answer, the minus b over 2a, because it doesn't matter if I plus or minus 0, I'm still going to get the minus b over 2a. If I have this b squared minus 4ac, if this is a negative, you cannot take the square root of a negative number. The very fact that we are taking the square root implies that the original number was squared, and positive numbers squared are positive and negative numbers are squared or positive. Minus times a minus is a positive, so you cannot take the square root of a negative. So all I need to do to show that this is not going to have two roots is show that the b squared minus 4ac is less than 0. So b in this case is minus 8. Minus 8 all squared is going to give me 64 minus 4 times 1 times 17. Double 17 is 34, so 4 times 17 is 68. 64 minus 68 is less than 0 because it's minus 4. So I have shown that the discriminant, which is what b squared minus 4ac is called, that's the name for that expression that is under the square root, the discriminant is less than 0, so therefore no roots, and the quadratic is all above 0. For all x. Right, part 2, we've got room to do that here. If I add 3 to a number and square it, the result is greater than the square of the original number. State giving a reason if this statement is always true, sometimes true, or never true. Now you can put different types of numbers in. I'm thinking if I put positive numbers or negative numbers. So say I put a positive number in, say 2, what we've got to do, add 3, 2 plus 3, and then squared. That's going to be 5 squared, 25. The result is greater than the square of the original number, and 25 is bigger than 4. But if I put minus 2 in and add 3 and then square, minus 2 plus 3 is going to be 1, and 1 squared is 1, and then the original number squared minus 2 all squared is going to be plus 4, so 1 is less than 4. So this is going to be sometimes true, and the reason is if the number is positive it's true, if the number is negative it's going to be false. Here's some simplifying of surds. Root 32 plus root 18. What you need to do with surds is rewrite the 32 with a square number times another number. So 16 times 2 will give me 32, and then 18 can be written as 9 times 2. So you can split this up. Root 16 times root 2 plus root 9 times root 2. Root 16 is a square number, so it's 4 root 2. Root 9 is a square number, so that's 3 root 2. So altogether, 4 lots of root 2 plus 3 lots of root 2 is 7 root 2. So A here is going to be 7. Now, quite often in A-level and at GCSE, you're using something you've just found in Part A to then go on and do something in Part B. So in Part B, it's using this as the numerator, so we can rewrite this as 7 root 2 divided by 3 plus root 2. Now it's not telling you what to do, but the way to get this all as a numerator would be to rationalize the denominator. So rationalizing this denominator would have to do times it by 3 minus root 2 over 3 minus root 2. Now you choose the top and bottom to be the same, so in effect you are timesing it by 1, so you're not changing the original value of the question which was here, but you're timesing it by the opposite sign, because when we times those denominators together, if we just multiply them together, you're going to get 9, the 3 times 3. Then because you've chosen the opposite sign, you're going to get minus 3 lots of root 2, but then with this one you're going to get plus 3 lots of root 2, so they're going to cancel each other out, and then we're just going to get the plus 2 times minus root 2, and the root 2 times root 2 will just give you 2, and the plus times the minus will just give you minus 2. So that is the difference of two squares effect when you are timesing it by the same bracket but the other sign. And then on the top, all we've got to do is times this 7 times 3. So that's going to be 21 root 2, and then 7 times minus root 2, and the root 2's times together will give you minus 7 times 2. So altogether we've got 21 root 2 minus 14 all over 9 minus 2, 7. We can take out a factor of 7 on the top, and that's going to be 3 root 2 minus 2, and that 7 on the front will cancel, so our answer will be 3 root 2 minus 2. So A is 3 and C is minus 2. Here's some questions on indices. So anything to the half. When you have a fraction, the number on the bottom means root. So because it's a 2, it means square root, and it's operating on everything in the bracket. So we've got to square root 9, which is 3, and then the 4 times the half. When you've got a power of a power, 2 powers there with the brackets, is 4 times the half, so that would be x squared. Part B, a to the 7 divided by a to the minus 3. The rule is that you take away, so then it'll be a to the 7 take away minus 3, and that minus minus in the middle is going to give you a plus, so 7 plus 3 is a to the 10. Power of power, you need to times these indices together, so that's going to be x to the minus 2 times minus 3 is x to the 6. With this one, part D, we need to square everything in that bracket, so that's going to be 4q squared minus q to the 7 over 2 all over q squared. Now you've got this minus here, so we can't do anything with those indices on the top, and we've got to try and give it in the form of a d minus a q to a power. So what we need to do here, it's these two terms in the numerator all divided by the q squared, so we can separate them out. We can say it's 4q squared divided by q squared, take away q to the 7 over 2 divided by q squared. Now when we've separated them out, we can see these q squareds will cancel, and that will just leave us 4, and then you take away here. So q to the 7 over 2 is really 3.5. 3.5 take away 2 is just going to be 1.5, so it's q to the 3 over 2. You could think of that 2 there. 2 whole ones in terms of halves is 4 halves. You've got 7 halves minus 4 halves, so that's 3 over 2. This next question is all about transformations of graphs. We've got this curve here, which is y equals f of x. It's got a max and a min, and we are being asked what is the effect when we times all the coordinates by 3, how will that affect the graph? And when we take away 4 from all the coordinates, how will that affect the graph? Now when you transform a graph, there are 6 ways we can transform. They come in pairs. We can either add and take away, and that shifts the graph up and down or left and right. You can times by a number, and that will stretch the graph, or you can make the graphs negative, and that will reflect the graph. Now it depends whether you're making the transformation before you've applied the function or after. Now what do I mean by that? We've got this 3 on the front, we've got f of x, so we've plotted the graph and then we've times it by 3. So this is an after effect because we've got the graph and then we're timesing it by 3, as opposed to f of 3x. So timesing all the input values and then applying the function. Now when we do the timesing after we've already plotted the graph, this is going to affect the y coordinates, and in this case all y coordinates are going to be times by 3. So if I draw the graph, Now, what are the y coordinates? Just looking at the 4, we need to times that by 3. So the new max will come up, and then the graph will come back down again. And these points here will be -2, and then 4 times 3, 12. This will be 3, and then -8 times 3, -24. Now the other point here, the origin, we can see it's still going to go through the origin, because 0 times 3 is still going to be at 0. Now this next one, we've applied the function and then we've taken away 4. So we can either do that, like do the function and then add and take away, or if we wanted to do the take away 4 before we applied the function, then we'd have the x minus 4. So because we've already got the graph and then taking off 4, this is going to have the effect of shifting the graph down by 4. And how you would write that as a translation, 0 minus 4. So when we've already got the function and then you're adding and taking away, it shifts the graph up and down vertically. When you do it here inside the function, so take away 4 and then apply the function, that would shift the graph left and right, but it would actually, if it was -4 in there, shift it to the right by 4. Okay, but this graph that we're being asked to draw is the whole graph shifted down 4. So we can see here with our y coordinate being at 4 up, that's going to shift down. So it's going to be at -2, 4. We're going to have 3, and then that -8 is going to shift down to -12. But this origin is also going to shift down. So it's going to come up, go through -4, continue to its min, and so that is going to be the coordinate -2, 0. This will be at -4, and this min here will be 3 minus 12. The next question is on straight lines, and we're given this equation of a straight line and asked to find the equation of another line that is parallel to the given line, but it goes through this coordinate here. Now you will meet at A level another equation of a straight line, but I will do this in a way you're more familiar with at GCSE. So if we want them to be parallel, they've got to have the same gradient. So what we know so far is the line we're looking for is going to be y is equal to -2/5 x and then plus c. It's going to be a different line, so it's not going to have the same y-axis intercept. But we are told that it goes through the point 3, 4. Now all coordinates obey the rule of the line. So the x coordinate is 3 and the y coordinate is 4. So if I feed them in here as x and y, that will give me just one unknown to solve to find c. So y is equal to 4 is equal to -2/5 times 3 plus c. Times in these two together, just times the numerators together. 4 is equal to -6/5 plus c. Now 4 in terms of fifths is 20/5, and then this -6/5 on the other side will be plus 6/5 is equal to c. So c is equal to 26/5. So the line I'm looking for is y is equal to -2/5 x plus 26/5. Now in part B, I'm being asked for an equation that passes through A again, but this time is perpendicular. Now when we think of parallel and perpendicular lines, if we just think of a more simpler line to explain, if I had y is equal to 2x, so fairly steep, and if I wanted a perpendicular line that went through the origin, what would be the equation of that line? Now the gradient is 2, that means for every one along 2 up, and for every bit that line is quite steep, the perpendicular line to get a right angle here needs to be a flatter line. And what happens is the rise and the run swap places, so we need to go 2 along and 1 up to get that right angle. And you can see that the 2x is going uphill. This one that's perpendicular is going downhill, so the m for the perpendicular line is equal to minus a half. So perpendicular gradients are the negative reciprocal of the given gradient. So because we've got minus 2/5, the gradient of the line we're looking for is going to be 5/2. So now we just need to feed it in like we did on the last one. Y is equal to 5/2x plus c. It's going through 3, 4 again. So 4 is equal to 5/2 times 3 plus c. 5 times 3 is 15/2. And 4 is going to be 8/2 minus 15/2 is equal to our c, because I'm just taking that to the other side. 8 halves minus 15 halves, c is equal to minus 7/2. So the line I'm after is y is equal to 5/2x minus 7/2. Here's a question involving circles and straight lines. This might have been one of the harder questions at the end of GCSE, circles that aren't centered at the origin and tangents to the circles. But we've got this circle that is centered at 7, 8, and we've got Q, which is the point 10, 13. And we're being asked for part 8 to find the length of that line. So annotating these points onto the diagram, we can see that this distance here is just the horizontal distance between 7 and 10, which is 3, and this distance here is just the vertical distance between 8 and 13, so that's going to be 5. So the length of PQ, we can just use Pythagoras. It's going to be 3 squared plus 5 squared, and then take the square root. So 25 plus 9 is going to be the square root of 34. Give your answer as an exact value, so it's just wanting us to leave it as that surd. Hence write down the equation for C. Now the equation of a circle is x minus 7 all squared plus y minus 8 all squared is equal to r squared. If the radius here is root 34, then r squared is just going to be 34. Now you might not have come across that equation of a circle, but if I just look at the equation of a circle that is centered at the origin, so if I think of a point on the circle, you can have points in all 4 quadrants. You can have them anywhere on the circle. Just looking at this positive quadrant here, if I have a point here that's x, y, so you go x along and y up, then the length to it from the center is going to be the radius. If I go to a point here, or a point here, or a point here, these are all going to be the radius along. Now, applying Pythagoras' theorem, it's going to be x and y. So if we just do x squared plus y squared, that's going to give me r squared. Now, even if the point is over here, if you like, this will be a minus number, so we might call it minus x, not really minus x, just a minus a number, and then it would be y high. But because we are doing minus x all squared plus y squared is equal to r squared, applying Pythagoras' theorem in any of the quadrants, even if the numbers to get to the point of the circle are negative, a minus times a minus, it will still be a plus. So this formula here is the formula for the circle. Now when you have circles that are not centered at the origin, say they're over here, say this is the point A, B, which is its center, and you have a point here, x, y, you're just going to apply Pythagoras' theorem like we've just done there, but this is x and then y to get to our point. And what is this distance here? Like we just did here, the difference between the 7 and the 10. This distance here is just x minus a, And similarly here, this distance is just the vertical distance, y minus b. So the equation of a circle is x minus a all squared plus y minus b all squared, again, is equal to r squared. You're just applying Pythagoras' theorem. So because our circle was centered at 7, 8, they go in as our A and B, and the radius, what we found in part A, was root 34, so we need to square it to apply Pythagoras' theorem. So that's part B done. Right, the line L is tangent to C at the point Q. Find the equation for L. Now, because it's tangent, our circle theorems tell us that a radius meets a tangent at a right angle. So we can see the gradient of the radius, the m for the radius, m stands for gradient, is rise over run 5/3. So m for the tangent is going to be minus 3/5, the negative reciprocal. We know that it goes through the point Q, which is 10, 13. So we're going to do y is equal to minus 3/5 x plus c, and then feed in our 10, 13 again. 13 is equal to minus 3/5 times 10 plus c, and then these will cancel, and we'll get 13 is equal to minus 6 plus c. So c must equal, taking the minus 6 over, plus 6, c will equal 19. So the equation of our tangent is y is equal to minus 3/5 x plus 19. The next question, we're going to use some trigonometry. We've got this triangular lawn being modelled by this figure, and we're being asked to calculate the area given these details that we've got on the diagram. Now, the area of a triangle is half base times height, but you can see we've got the base, we haven't got the height. But the other formula for area of triangle that you had on your formula sheet for GCSE is half AB sine C. So this is two sides and an included angle. So we at the moment we've got two angles and an included side. So what's going to be useful is if we find this side or this side. Now, because we've got these two angles, we can use the fact that angles in a triangle add up to 180. So this angle at the top here is going to be 50. Now you can choose to find any of them. If I say that this is little a, it's going to be side little a over angle A, sine 70 is equal to 30 divided by sine 50. Now just cross multiplying, a is going to be 30 over sine 50 times sine 70, and when you put that in your calculator you will get 36.8, and then we can use this half AB sine C because we have two sides and an included angle, and that's how that formula works. So the area is going to be half times 30 times 36.8 times sine 60, which on your calculator comes out to be 478 meters squared. Now it's asking you part B, why is this unlikely to be an accurate answer to the nearest meters squared? In the question, all our values are just given to two significant figures, so we could only give an answer accurate to two significant figures, or the fact that maybe this lawn isn't just a flat lawn, it has, you know, humps and bumps and it's uneven, so maybe it won't be accurate to the nearest square meter. Some GCSEs required you to know your exact values. There's different ways of remembering them, but I remember two special triangles. I remember one fact: sine 30 is equal to a half. Now sine is opposite over hypotenuse. So that means when I have a right angle triangle and I have the angle 30, then the opposite and the hypotenuse must be in the relationship of a half. So if the opposite was 5, the hypotenuse would have to be 10. If the opposite was 16, the hypotenuse would have to be 32. But it all boils down to you having opposite 1 and hypotenuse 2. Now, by Pythagoras, if we square 2, 4 and take away 1 and then take the square root, the adjacent here must be root 3. That's just applying Pythagoras. Now, angles in a triangle add up to 180. We've already used 90 for our right angle triangle, so the other two must sum to the other 90, so that angle there must be 60. So from that, I can get sine, cos and tan of 30 and 60. Sine 30 is a half. Sine 60 is opposite over hypotenuse, that's root 3 over 2. Cos 30 is adjacent over hypotenuse, root 3 over 2. And cos 60, well, what was the opposite for the 30 is the adjacent for the 60, so that's a half. Tan 30 is opposite over adjacent, 1 over root 3, and tan 60 opposite over adjacent is just root 3 over 1, which is root 3. Now from these exact values, I can just put them in here. Tan 30, which was this one here, 1 over root 3 times sine 60, which is root 3 over 2. They're going to cancel and it's just going to be a half. Thank you so much for watching. If you stayed with me to the end, hopefully that's given you a flavour of what to expect for your maths A level, going through the topics that are going to be involved in the lower six and giving you a little bit of a head start, getting ready to start in September. But have yourselves a great summer. Do have a look at some maths and get yourself really sharp and ready to start your A levels. That's going to be really useful to look at those topics. Now, the questions I've used, I will put a link in the description. They are all taken from the Edexcel transition from GCSE to A level series of question papers, and online you'll find mark schemes as well. Okay, have a great summer. Thanks for watching. See you on the next one.